Hello, folks. Here I am in the top right corner. Woo! All about going through your reaction time lab. I want to make sure everyone is on the right page so we can do all of this together. So on the front page, you'll recall we have the directions. You should have already done this. And then your job was to catch a falling ruler as fast as you could with your left hand and then with your right hand. So here I have data only for my right hand. You should have data in both places. You can see all of my decimals, and then I took the average. You just add them all up and divide by 5. I also want to point out, because a lot of you had this, is there is some consistency between trial 1, trial 2, trial 4, but then trial 3 was just super fast in trial 5. I don't know what happened, but because we're taking an average, that range is okay. If you have a more consistent range, obviously you just add a little bit better data. Turn the page. And now we talked about this. Based on your discussion, list all the stuff that we know. We're working with those kinematic equations from the MCAS sheet, the motion equations. So things that I would know: the initial velocity, how the ruler started, my average displacement, delta x is my change in distance or displacement. So I took the average from my experiment, 0.398 meters. Again, you should have two, one for your right hand, one for your left hand. The final velocity, I don't care about except for the bonus, which I'm not going to go over for you because that was bonus. The acceleration is the acceleration of gravity, what makes things fall down. The goal of this experiment is to solve for time. That's what you need to find. How am I going to do this? I'm going to do with finding the MCAS equation. Delta x is vi delta t plus 1 half at squared. And again, I crossed out that initial velocity. You should know why. There's a hint. Now, to go through the guess method, this part, I'm sorry, I skipped. That is what you should understand and know. To go through that guess method, that's what I laid out here. List all the things that we know, the givens, the initial velocity, the acceleration due to gravity, the final velocity we don't know, the time we don't know. And again, this was my average right hand distance, 0.398 meters. You will have two. You will do this two times, your left hand and your right hand. I selected the right equation from the MCAS sheet. Delta x is VIT plus 1 half t squared. There should be little deltas there. I just dropped them out. Then I subbed in my numbers. So this was the given equation. Substitute and solve. This is my substitute. 0.398 equals that's 0. Hopefully you know why. Plus 1 half times the acceleration of gravity times t squared. My note here, I'm not going to do the solving for you. You need to do that. But I got a time of 0.28 seconds. Your time should be different. Now, oh, that's the hover cam. There we go. Now you should have two times again for your left hand and your right hand. My note, if you have a time that is 0.5 seconds or higher, that likely means you did something incorrect. Now, we're going to analyze your results. You see, I couldn't get my acronym right, but this is something you need to do. That's why I say LFYTD, left for you to do. This question number 2, are your reaction times consistent? You are actually going to compare your times from your left hand and your right hand. Are they close? Are they consistent? If they are, tell me why. If they're not, tell me why you think they're not. Now, this section was a computer section. You needed to go to a website that I posted to Google Classroom, click, 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 click to catch your reaction time. Same thing, I wrote those 5 times down. I took the average. My average time was 0.236 seconds or 236 milliseconds. Now this question, this should actually be 1, 2. This should be question 4, not 3. Are reaction times consistent? You are going to compare to this time with your left and your right ruler drop times. Are they the same? Are they close? Are they different? Give me an explanation on why they are different or why they are so close to being the same. Now your conclusion. This might be a little complicated, so I did the best I could. You can see there's a whole lot of stuff here, but this says there are reasons why your reaction time might be slowed down. It might be slowed down by 30, 50, or 20% as explained in this paragraph. So what I did is I went through one example. So you're going to look at your data and find your fastest reaction times. You had 3 different times. Left hand, right hand, computer. Find your fastest time. We're going to use that time. Mine was 0.236 seconds. I'm going to do one example, slowing down by 30% or 0.3. So you take your reaction time, 0.236, and if it's slowed down by 30%, that's 0.3. I multiply my reaction time times 0.3. That gets me some very small number, and then I add it to my reaction time. So what that looks like on the calculator, 0.236 times 0.3. That is adding time. So for 30% reduction, that's 0.0708 seconds. I add that to my initial reaction time, 0.236. And now my new reaction time, if I'm slowed down by 30%, is 0.3068 or 0.307 seconds. So you can follow my example. You have to do that 3 times. Now the conclusion says if you're traveling at 65 miles per hour and you suddenly need to stop, how many feet will you go before you hit the brakes? In other words, you're driving along, driving. Oh no, there's a dog. Slam on the brakes. The amount of time it takes your brain to react to the dog, you haven't hit the brakes yet. So you're still traveling at 65 miles per hour. That's what we're going for here. So what I do, the first step is to convert 65 miles per hour into feet per second. So we've done this in a lab before. You need to fill in the blanks. I gave you the conversion factor, 65 miles per hour. We need to go from feet to miles, and then hours to minutes and minutes to seconds. I did not give those to you. You should know them, but I gave you the feet. Now, I made this number up. 200 feet per second is the wrong answer. If you use 200 feet per second, it is not correct. So I take my made-up answer, and we're going to use the same equation, the delta x equals VIT plus 1/2 AT squared equation. You need to do this 2 times. Once undistracted, your fastest time, and then once distracted, using your distracted cell phone time, which is 0.2 or 20%. So what I did here is I said my delta x is my initial velocity times time plus 1/2 AT squared. And there's no acceleration because I'm just driving at a constant speed because I did not react yet. That's what we're trying to figure out. So my 200 feet per second that I made up times my reaction time comes out to about 47 feet. So what that means is as I'm driving along, something runs into the front of my car. I'm like, oh my goodness. Or like if I were biking and some woman was driving out of a, car dealership in Watertown and she drove into me. She would have driven 47 feet, which was enough to possibly hit me on this past Monday. She would have driven 47 feet before she even reacted to me being in the road. Anyhow, that's all I have. I'm hopeful that this breakdown will help you finish your lab. This last page, you can see this is extra because of all the time that I've been out with the accident. So we will do this in class one day. It'll take about 15 minutes and we'll go through it. It'll be a fun kind of activity. You do not need to do anything with this page. Thanks so much. If there are any questions, by all means, ask in class and/or send an email.